So now we'll be solving question number 10 from previous year problems. Chapter is laws of motion, phase 1. So this is the question which came in 2003. This question came in 2003. Let me read the question. So what is the maximum value of force such that the block shown in the arrangement does not move? So this is the block. The mass of the block is root 3 kg. The mu is given as 1 by 2 root 3. And the force is acting at an angle 60 degree with the horizontal. The value of force we have to calculate. And they're talking about the maximum value. And as we know, like whenever friction is there and somebody is asking about maximum, minimum or something critical. So this is the critical condition. Critical case, friction make it Fk, acceleration 0. Force may need. Don't have to think basically whether they are asking maximum, minimum or what. Just use this case, whatever they're asking that you will get. Now, let me make the FBD. FBD of this block. So the force is basically downward will be mg. Let me write the mg only. I'll replace the mass at later stage. Then we have a force acting here. This angle is 60, so this angle will also be 60. Let me write this angle as theta for a time. Force is F. So I'll decompose. So one will be F cos theta and one will be here F sin theta. Now downward forces will be balanced by the normal reaction and the horizontal force F cos theta will be balanced by friction. Critical condition is friction is Fk, acceleration is 0. The moment you put it, whatever you are calculating, maximum, minimum or F, theta or anything, will automatically will get. Now, since I'm going to calculate the Fk, I'll need the Fk. First, I need to calculate normal reaction. So from normal, I can get Fk. So balance along the vertical. From balancing along the vertical, N will be equals to mg plus F sin theta. That makes the Fk value as mu mg plus mu F sin theta. I'm not writing the mu value right now. In the end, I'll write everything. This is your Fk. Now let's go horizontal. So along the horizontal, F cos theta will be equals to Fk. So F cos theta is equals to Fk, which is mu mg plus mu F sin theta. Let's bring it here. Take F common. If I take F common, I'll get cos theta minus mu sin theta is equals to mu mg. F will be equals to mu g divided by cos theta minus mu sin theta. Now let's write the value. The mu is given as 1 by 2 root 3. Mass is given as root 3 mg. Root 3 kg. And the g is 10. Divided by cos theta, which is theta is 60. So cos 60, 1 by 2. Minus mu, which is 1 by 2 root 3. Sin 60, which is root 3 by 2. When we will finally solve it, the final value will come out to be 20 Newton, which is, again, always remember, like the moment friction and something maximum, minimum, critical or anything like angle they are asking, force they are asking, anything, maximum, minimum, you immediately go for critical condition when friction is there. And critical condition is you make friction as kinetic, acceleration as 0. Whatever they are asking, automatically you will be getting. Okay. I hope you understand. Thank you.